Are you going to take my picture? Okay, good. Be sure to get my good side here. The Lab Safety Institute is one that's been in existence for probably 25 years, a long-time safety service provider in a lot of different ways, universities, K-12, business and industry, and also the International Committee for Associations of Science Education, the ICASE, and so we're kind of intertwined in that. And I've been working, I guess, with Lab Safety Institute for about 20 years now, and it's been fun. I'm not going to Alberta, but I am. We work with the Department of Defense, do a lot of training for them, and that takes us to Italy and Germany and Japan, and that's kind of been fun for someone who actually has a full-time job. My full-time job is at Texas State University, San Marcos, which is near Marcia. We're longtime colleagues, and I teach science courses for teachers. I teach the science methods courses. I teach the supervise the science student and math student teachers. My research area is safety, so this is one of the reasons how I got into it a number of years ago when we adopted the Hazard Communication Act, which is dealing with hazardous chemicals. And it was kind of interesting. I taught public school for 18 years before I moved to the university, and I was a high school department chair then, and this new law came into being, and no one knew what it meant. It says something about 500 pounds, and I thought, well, I don't have 500 pounds of anything except microscopes, and, so it took a while for us to figure out what all of this meant. At any rate, what I've been asked to do is to give you a short focus on safety and reviewing some of the globe protocols. We're going to look at some of the aspects, and I'd also invite you to ask questions about any of the things that you might be thinking about as we go through this. The issue of safety is something that I have been interested in, as I said, for a long time, for a lot of different reasons, one of which I already mentioned was the new laws that were requiring it. And I actually went into some of the safety research areas, and there's very few of us who are around. And in fact, I have the research on overcrowding linking to increased accident rates. And that was enabled us to be able to get in Texas our facility standards to where the labs have to be a certain size to accommodate, and if they're going to put any more students in that, they have to add additional space to it. So let me go over here, since we don't have my students called a clicker. Okay. Early on, we want people to think about what the legal aspects are. And so as you're going through your own activities and your students' activities, or you're training others to do so, to be sure and know what the legal requirements, what are the federal and the state requirements for your area that you're working in. And if you're working, I know you're working internationally in many cases, and there are, a whole range from almost nothing to very strict requirements for safety. And then, of course, at the district or the school level. I was given a few of the GLOBE protocols. I am not a GLOBE user. I do have a colleague, though, who is. She teaches in our science course for pre-service teachers, and she is a GLOBE collaborator, I guess you would call them. In the protocols that I received that were samples, I looked at the materials and the tools and the safety precautions, and those components have safety precautions in there. I was specifically asked to look at chemicals, and so when we think about safety, we want to think about how to safely use them, how to safely store them, and how to safely dispose of them. Well, what's the acceptable number of times that you would like acid in your eye? I think most of us would answer 0. So when we talk about hazardous chemicals, we always want to match the hazard and the protection. So you have a number of protective eye devices depending on what you're using. If you're welding, then you use welding goggles or glasses or helmets. If you're using things that have involve projectiles, and you need something that's going to protect against that, as well as the hazardous chemicals. So if you're looking at these 6, I'd like for you to talk to your neighbors at the table and decide which is the best choice of these. I don't know. Talk about that. Yeah, I'm leaving that wide open. What's the best choice here? I'm going to give you about 1 minute. Okay, who knows their eye protection? Let's see. Okay, we have 6 choices up here, and we have 1, 2, 3, 4, 5, and 6. All right. So if we're talking about chemicals, what's the bottom line? What do your globe protocols say? What do they call the eye protection that you're supposed to be using? Anybody have any protocols they can look at? What does it say? I think it says safety goggles, okay? That's, pardon? No, it doesn't say splash. It doesn't say splash. It says safety goggles. So if it should be chemical splash goggles, will number 1 work? What about number 2? Maybe. What about 3? No. 4? Looks like it. 5? 5 are the Flynn visor gogs that you can do this with. Okay, and 6? Maybe. Okay, go ahead. Okay, well, number 1 doesn't work because it is ventilated, which has direct ventilation in it, has holes in it, and so this is a very common goggle that you see. This is a woodworking goggle. A woodworking goggle, which means that it would protect against projectiles, but it is not a chemical splash goggle. And so quite frequently you'll see problems with goggles out in the classrooms, or perhaps in materials that you use. This one is an indirect vent, which you can't see very well, but it will have an area up here around the edge in which the air can go in and through in many cases. Okay, next one. You are looking for something that will protect against projectiles, you need the ANSI standard Z87.1. And so if you look here, you can see the Z87 standard. That's a projectile. If you wear glasses, you probably have a Z87.1 shatterproof standard in there. So it's a projectile protection. And I used to think when I was a science department chair that I was doing such a great job ordering all these goggles for my students and the teachers, because I'd get that ANSI Z87.1. I didn't understand about the chemical splash part of it. Okay. One reason that I'm focusing on eye protection is because eyes are so fragile. You can lose them just like that. I mean, you can lose complete sight just like that. There are other hazards in using chemicals, but I think the eyes should have a particular focus on them. So an eye wash which is also critical, needs to be a dual. That means that you must be able to wash both eyes at the same time, and you want the water to actually be able to turn on. I often go into labs and I'll ask the teacher, well, how's your eye wash working? And the teacher will say, just fine. And I'll say, well, let's see. And we turn it on, and there's maybe, a little dribble of water coming out, or it's coming out like that at an angle. Pardon? Yeah. And essentially what you want is you want it to come over, and you want it to arc like that, so that when you bring it over, that it's going to hit both eyes at the same time. It also needs to be hands-free, because have you ever washed your eyes out in an eye wash? Here's what you do. So you have to be able to keep that eye open, both hands, because it's not typically going to get in just one eye. If it's a splash, it's going to get into two eyes. Now, in my experience, though, I have not seen as many splashes of chemicals in eyes as I have seen contaminated hands putting their fingers in there. And so there should be a rule that says that you don't take your goggles off until you completed cleanup and hand washing. Then the goggles should be or could be taken off. There needs to be a minimum of 15 minutes so that you can wash your eye out for 15 minutes, both eyes for 15 minutes. The hands-free component of this is this lever here. So all you have to do is come in, turn it on, and they both come out, and we'll wash them for 15 minutes. It also needs to be tepid. Tepid can occur either with having a warm water line to it, or in some cases the water can be stored in a tank like in the basement, and so it becomes building level temperature, if you would. And it also needs to be flushed weekly, so you're flushing any kind of physical or biological contaminants out. There is an amoeba that can live on the surface of the water here that can cause encephalitis, and so you want to flush it out, as I said, just weekly. Just turn it on, for a minute, not long, and flush it out. We actually have had a couple of children die from swimming in water that's warm and still and kind of stagnant, if you would, near Austin, from getting this amoeba with the encephalitis associated with it. Okay.
Can we interrupt you?
Yes.
So what if we're out in the field and, we're doing with the Lamont kits, and we have the chemicals and stuff, and somebody gets in their eye? What would you recommend for eye wash?
Well, the first thing is they should not be using any chemicals without wearing the goggles the full time. That's the first thing. So there has to be some kind of accountability for making sure that eye protection is there full time. The second thing is that they shouldn't be taking it off any time that they have, they're using any of the chemicals. It's not putting it, up on the top, et cetera. Right. And a lot of people tend to do that. The other thing that I would say in terms of what Marcia's talking about, there are the little squeeze bottles, and the squeeze bottles are not a substitute for an eye wash. The squeeze bottles go back to the days of the chemist, where you've got the chemist that's sitting in the lab bench. They get something in their eye, they grab the water bottle, they squeeze it in there, then they go to the eye wash for 15 minutes. Somehow that got translated as being an eye wash, and you saw lots of those little green bottles that were mounted on the edge of the walls for that. So in terms of taking something out to the field, that I think would probably be your best bet. But mainly, keeping teachers and students trained, and I think the other part of that is making sure that you get goggles that fit well. You want them. The cheap ones will have an edge around it that is kind of sharp, and it's not comfortable. And so, you need to spend enough money so that you've got comfortable goggles. I think we had a question over here.
Well, you kind of answered it. With regard to a lot of our elementary schools,
Mm-hmm.
that is an impossibility, because that's a retrofit. And so they all have the squeeze bottle.
Mm-hmm.
So the thing is, it is a worst-case scenario. If you have nothing else, use the squeeze bottle. But keep them clean so they don't accumulate.
Well, not only that, so that they're not deliberately contaminated. There have been instances in which students have spit into them, et cetera. So you have to, think about this. But there's also, go ahead, Marcia, with the next one there. There's also ones that can be retrofitted onto a faucet. This is what we would call a two-stepper. In this case, you would have to hit this, and these little cups would pop off of the eye wash there. But you have to swing this over the sink. You also have to work with plumbers. One day I was in a lab, and I asked the teacher if they had the eye wash. She said yes, that they had just put it in. The plumber had put it in, and it was on a demo. Now, in terms of building new science facilities, we do not recommend that you build one of those demos. We don't teach by demo anymore. That was back when I was in junior high school, and that was a long time ago. And so, at any rate, she had this demo desk with a sink. And I said, okay, now let's think about this. Now, I have to tell you, I am a Texas Aggie. Whoop. But, we can reason through some things. I said, now look, if you swing this eye wash back over this sink, you're going to have to do this. Whoops. You're going to have to climb on top of the demo table to use it. So the plumbers don't understand the use of these things. And you have to work with, have to do that systems thinking and work with a lot of different components. But there are retrofits that they can put on sinks for the eye washes in there. And usually the nurses have gotten better about having eye washes, not just the squirt bottles in there, because they know the 15-minute rule. Contacts are okay. Often people will say, I'll get to you. Often people will say, don't wear contacts in the lab, and they'll have lab contracts that say no contacts. There's no scientific evidence that is should be required. In fact, there's scientific evidence the other direction, that there is no greater damage to eyes if they're wearing contacts than when they're not. The only time that you really see a problem with contacts is in the industry level, where you've got really toxic kind of fumes that can permeate those permeable contacts. So that's not usually a problem. Yes?
Going back to the which kind of goggles to use, in New York City, they has a requirement that they have to be sanitized on a regular basis. Is there...
There's a number of ways that you can sanitize them. Usually the problem for sanitation has to do with pink eye. And so that's the way that you can do it is you can do it with warm soapy water. So you can do it with tubs. You can dip it into a warm soapy water, dip it into a tap water, and then dip it into still water and let it air dry. You can also do the same thing with a 10% Clorox solution. Of course, someone should be wearing goggles who's doing that. And then you can do it with the UV sanitizers. Yes, but those are like $300. Yeah. But you also, if you're going to use a UV sanitizer, you need to make sure that the light shines into the goggle. Don't turn it around this way. Turn it around where the light shines into it. Okay, this is the two-step one that I mentioned earlier that's kind of a retrofit. This is called a body drench or a face drench. This is not an eye wash, and this is not a sink. Go ahead. The other thing that you might want to consider, depending on what kind of activities that you're doing, is whether or not you need a demo shield. When we're talking about hazardous chemicals, there are things, kind of activities that teachers will do as demos, and they all need to have some kind of portable shield for it. Most accidents are cuts and burns. Burns from fire or burns from chemicals. And so we need to think about, when we're looking at these activities, is what's most likely and what's most serious. With gloves, you need to match the protection with a hazard. The protocols that I looked at had latex gloves, and of course you've got more people who are becoming allergic to latex, and so you always, want to identify that. Fire control. This is a huge issue. This is a fire at Texas Tech University. They were storing incompatible chemicals in the fume hood, and so you can see how devastating that can be. Go ahead. And this is what kind of devastation it can cause to a human body. This is Autumn Burton. She was in a high school chemistry lab, and they were actually doing the flame test, and it burned her over 50% of her body. And this is a technician who you can tell is also has some kind of injury here, showing Autumn how to cover up all of those burns. You can see them here and here. Hazardous chemicals, flammable ones, to me, are one of the areas that need to be looked at. This is also another student. This is Taylor Deltz, who was burned in an accident, and you can see him there on the right. Well, if you're dealing with hazardous chemicals, you need to make sure that you review the material safety data sheets. As I said earlier, it will tell us how to safely handle, store, and dispose of hazardous chemicals. You also need to know about the labeling requirements for the primary containers, which is the name, the hazard, and the company, and the secondary label on the secondary container, like when you're transferring chemicals, it has to have the name and the hazard on it. There's some other useful information, but primarily that. The focus on safety should be constant. It should be initially. I don't mean teaching safety for the first 3 weeks. You know, I'm probably known as the safety queen of Texas, and I'm not saying that, but there should be certainly some initial instruction. But it also should be as needed. You know, just in time kind of safety information for each activity, and then safety should be incorporated in each of the assessments. So that's it in a nutshell for safety of things that you need to consider, particularly about hazardous chemicals. We do a 24-hour safety training at my campus every summer, so you can see there's a lot more to it than what we've done, but this is a kind of an alert for you. Mm-hmm.
And so what I'd like to ask is that everybody at your table, please, what I'd like you to talk about, everybody here, you're from Globe Partnerships, you conduct Globe trainings. I'd like you to talk quickly amongst your table what types of safety precautions you already include in your training, or maybe those that you might think about starting to include in your training. So let's go 2 minutes, quick. Hey, thank you. We've got some really great discussions, and I hope that they continue well into the future, because this is really a critical issue for us at Globe. And Bill wants to talk just about, for 30 seconds, about something that he brought that he'll put over on the table in case you're interested.
Hi there. One of my roles with the Calgary School Board and having 250 schools is I wrote their safety manual, which regarded all the sheets on hazardous materials and how to deal with them and so on and so forth. And what we have a tendency to forget is the elementary classroom. And we have very good things for high school. And a lot of our teachers in high school teach science are very, very, well, they're experts in their field of study. So we prepared a huge manual, and the province has now taken that manual, and the Western provinces are using that manual in terms of being prudent. You can't think about everything, but you've got to be able to show that you've taken proper precaution. We've had kids who have taken alcohol because they got kicked out of a lab and put it into drinks for other kids. So we've been there, we've done that, everything's happened. So I'm going to pass this around. This is some basic stuff that we use in terms of safety, and you actually adapt it to your level of your students.
Thank you. And one thing, and Sandra, where did Sandra go? Sandra, did you also bring some handouts or anything, or is there a booth or something here at NSTA that they can stop by to get your information? Okay, Sandra's going to place her information out on the table as well for people to pick up.
I'd just like to say that for safety, sometimes you have to look at the landscape. And when I first started training, taking the kids down to Beargrass Creek, it was in a raining session, and it was in a preserve, and so it came around the curve, and so there was all this sand buildup. There was actually grass growing on it, and we were walking, and the kids were a little ahead of me, and they wanted to get down to the water. One of the 8th grade boys went down and immediately sunk in the sand up to here. My God, it was scary. And we did not have a rope. That was the one thing I knew I wish we had to keep him from going. Well, I sent the kids scattering for 911, and they came and they got him out. But I think that's another thing that it was a terrible learning lesson for me, but there are also other dangers there as the land changes.
Absolutely. Thank you, Sheila. And, we've heard a lot of different types of stories from schools and things that have happened. And so, this is something that is really on our minds. We're looking at right now at modernization of the Globe Teacher's Guide as well, and this is one area that we're going to be looking at adding to, hopefully, in the future. So thank you very much, Sandra, for the great presentation. And